Hi everyone, welcome back to the channel. Today I'm going to show you how to analyze dose distributions using a DICOM RTDOSE file. No TPS needed. We are going to convert a standard RTDOSE file into an EQD2 dose distribution directly in Python. This is a full DICOM-native implementation, and you'll be able to load the EQD2 dose back into your RT system for visualization. Let's get started. In DICOM RTDOSE, the dose isn't stored in floating point gray values directly. It's stored as unsigned integers, and you recover the actual dose by multiplying actual pixel value with the DoseGridScaling value. So here in this script, we are reading in a RTDOSE file and we are writing to an EQD2 dose file. We specify the alpha beta value and know that this is in the unit of gray, and therefore our dose matrix when read in also needs to be in gray. And here is the popular formula. To implement it, the key is to make sure the dose we are reading in is in the unit of gray, which is consistent with the alpha beta value. For example, here 2.0 gray. We will use the pydicom to read in the RTDOSE DICOM file. Then we will check the units to double check if it is in gray. And in this case, we are reading in the total plane dose instead of individual beam dose. As I mentioned earlier, in the DICOM RTDOSE file, the dose, to recover the dose, we need to use the pixel value times the scaling. And the scaling is in DoseGridScaling. And when we write out to the EQD2 dose, we also need to be mindful that our dose scaling is such that the pixel value do not exceed the max bit number. For example, if your system is a 16-bit system, the maximum value can be stored is 65535, and you want to pick a dose scaling value such that your pixel value do not saturate. Another key when we write out the RTDOSE file, we need to assign a new series instance UID and SOP instance UID so it can appear separately from your original dose file if you want to import this EQD2 dose back into your system. Some systems also require you remove the reference of the RT plane. So this is optional. Now let's run it. This is very quick. We are reading in RTDOSE corresponding to 5 fractions, and we calculate the EQD2 dose using alpha beta 2 gray. We also pick a DoseGridScaling factor such that the maximum pixel value does not exceed the 16-bit maximum. Next, we will use a 3D slicer to visualize the dose. And let's first load in the original dose. It is in this folder. We are reading in only the CT and the dose file. And next, I'm going to copy this dose into a folder because the load file function is not quite robust. So I copied the EQD2 dose we just generated, and I'm also going to use the load from directory function to load the RTDOSE. It appears at under the same patient name, and you can see we have the original dose and also the scaled EQD2 dose. Now we can load into the 3D slicer visualization tool. And here we can load the original dose in this panel and the scaled RTDOSE in this panel. I'm still not very familiar with the system, but we can also load the CT, and we can change the blending so we can see both. Let's change the blending a little bit better. And we can do the same thing in this panel. This shows the RTDOSE, and we can blend with the original CT. And if you hover over, you can see the original dose. This is 55 gray. And after scaling with the EQD2 for 5 fraction alpha beta 2, it can go up to 200 gray. And we can verify it is correct. So that's it for the demo. If you find this useful, make sure to like and subscribe, because I'm planning more videos on DICOM and automation tools for medical physics. You can download the full script in the description. Thanks for watching, and see you in the next video.